There we go. Okay, so we're looking at number 7, the hydrogen ion concentration in that solution of a weak base is 1.51 times 10 to the minus 10 molar. And we want to know what is Kb for this base. Now, we don't have a formula for this base, so let's just let B be the formula. Of the base. Can you guys like write notes to each other instead of chit-chatting? Noah, Beta, can you guys write notes to each other instead of chit-chatting? You're just asking what? The page. Okay. We are on page, what the heck page are we on?
29.
29, thank you so much. Page 29. All right, and now, just like in our KSP things, we need to write instead of the solubility equilibrium, we need to write the weak base equilibrium equation. The WB. Okay, so we have B, which is, what state is the base? Aqueous. And what does it react with? H2O, which is a liquid. And that is in equilibrium with, what does the base become? BH plus or HB plus, whichever one you prefer, plus OH minus, and those are aqueous and aqueous. Now, when it is a weak base, what tools should we use? Rice and KB. So let's do our RICE. Water doesn't get included in that because it is a liquid. Now we have a 0.1 molar solution of the weak base. Is that the initial or the equilibrium concentration? That is always the initial. Remember when it was a weak acid, whenever I gave you a concentration, it was always the initial concentration of the acid? So this is the initial concentration of the base. So if you are given a concentration of a weak base, or if you are asked for a concentration of a weak base, it's always the initial concentration. For a weak acid or a weak base, WA, WB, the concentration of the acid or base is always the initial concentration. Okay. So that means that our concentration of the base initially is 0.1. Is it 0.10? Yes, it is, 0.10. And the other information that we are given is that the concentration of hydrogen is 1.51 times 10 to the negative 10 molar. Can we put that in our equilibrium anywhere in our Rice table?
For the final.
It is going to be a final. We need to convert to concentration of OH minus. So
How do we know 1.51 is the hydrogen? There's
the H plus concentration in a solution of the weak base is that. There's a clause in the middle of the sentence. Yeah? So that requires a little bit of careful reading. Yeah? And this is our equilibrium concentration, so we'll be finding the OH at equilibrium. And how do we calculate OH at equilibrium? KW over hydrogen. So that's going to be 1 times 10 to the negative 14 divided by 1.51 times 10 to the negative 10, which is 6.62 times 10 to the negative 5. So I'm just going to call that 6.6 when I put it in my table, just to make my table tidier. So this is going to be 6.6 times 10 to the negative 5. And what were my initial concentrations of my BH plus and my OH minus? 0. So this is going to go down, this is going to go up, this is going to go up. 6.6 times 10 to the negative 5. Should you be putting an X in here? No, because it's not an unknown. And because it's all 1 to 1 to 1, though, everything's going to be 6.6 times 10 to the minus 5, 6.6 times 10 to the minus 5, and 6.6 times 10 to the minus 5. And now this is where you get to use your judgment. Is 6.6 times 10 to the minus 5 going to make a difference to the number 0.10? No, because it's way too many decimal places away. So you can just say that that is equal to 0.10. Okay? Now, what if it weren't 6.6 times 10 to the minus 5? What if it were 6.6 times 10 to the minus 3? It would change the concentration enough because it's close to the, like it would cause a rounding difference. Yeah? So you have to make sure it's at least a couple of decimal places over from where you need it. Okay? So if your number goes to 2 decimal places, like this one does, you would want it to be at least starting at 4 decimal places or less. Yeah, you want a difference of at least 2 decimal places, a factor of 100, before it's insignificant. But you can always do the subtraction if you want to, just to be on the safe side, right? You can be like, I'm going to just chuck that in my calculator because I don't want to be wrong in my assumption there. All right, and now we can do our KA. No, What can we do? We can do our Kb because we have hydroxide. And because it says base. Okay, so Kb is equal to Hb plus OH minus over B. And we have 6.6 times 10 to the minus 5 squared over 0.1, which is equal to 4.386 times 10 to the negative 8, but we are going to go to 2 sig figs, so that's going to become 4.4 times 10 to the negative 8. Is good? Okay. Any other questions from the homework? Alrighty. So today we are going to go back to using acid-base indicators, which is on page 10. So one of the things that you can do with acid-base indicators is you can use 2 or more indicators to find the pH range of a solution. So you'll be given some information like a solution turns phenolphthalein pink and it turns indigo carmine blue. What is the possible pH range of this solution? So what that means is you've taken the solution, you've taken a sample of it, and you've added some phenolphthalein. The phenolphthalein turns pink. You've taken a second sample, and you've added some indigo carmine, and the indigo carmine turns blue. And now we're like, okay, well, what color does that mean? Well, phenolphthalein is pink at pH 10 and above. Okay, and we've shown that in this little diagram here. Here's our phenolphthalein. It is pink above pH 10. So we know that our solution has a pH greater than 10. Indigo carmine is blue, and that means our solution is less than 11.4. Remember, whatever color is on the left corresponds with the pH that's on the left. Sorry, yes? Can it be? Well, you know what? I'm never going to give you like a 10, or we could say greater than or equal to. Okay? No big deal, either way. And our indigo carmine is going to be blue, and so that is below 11.4. So the pH must be less than 11.4. So the pH is bigger than 10 or less than 11.4. Or you could say the pH is between 10.0 to 11.4. Or you could write 10.0, no, to 11.4. Now, why am I not getting too worried about whether it's greater than or equal to or just greater than? Okay, it's because we are approximating the solution pH anyway, right? We're like, it's somewhere in that ballpark. So I'm not too concerned if it's like 10.1 to 11.3. You know what I mean? Like, I'm just not that concerned. As long as you've got those two endpoints on the range, I don't really care whether it's greater than or equal to. Does that make sense? Okay. Oh, look it. I even wrote that in here. Does it matter that one of the ways of expressing says that the range includes 10.0 and 11.4, and the other says that the range is greater than 10.0 and less than 11.4? No, it does not matter. Indicators are very imprecise in their measurement of pH. When does the phenolphthalein cease to be pale pink and start to become pink? When does indigo carmine cease to be greeny blue and become pure blue? Yeah. So we're not going to worry about it too much. You can write the range either way, and as long as you get the n values correct, I'm not going to worry about it. Okay? Also, I'm never going to ask you what is the color of indigo carmine at pH 13. Let's go look. Indigo carmine at pH 13. Is it yellow or is it green? Am I going to ask you that? No, I'm either going to say the pH is 13.1. Is it yellow or is it green? You're going to say yellow. Or I'm going to say it's 12.9. Is it yellow or is it green? And you're going to say green. Okay, because it's just not worth getting fussed up about something that is so approximate anyway. All right. Finding the color of an indicator in various solutions. When asked to find the color of an indicator in a solution, you will need to find the pH. So if we are asked, what color will bromcresol green be in hydrogen ion 1.9 to 11.2, 1.9 times 10 to the negative 11. That's what I'm trying to say. And bromcresol green at 3.8 and below, it is yellow. At 5.4 and above, it is blue. And in between those two, it is green, because yellow and blue make green. So in order to tell what color it will be, you need to figure out the pH. What's the formula for pH? pH is equal to the negative log of the concentration of hydrogen, which is equal to the negative log of 1.9 times 10 to the negative 11, which is equal to 10.72124. What would my final answer be? 10 point what? 10 point anything?
10.72.
10.72, yes. Because we have two sig figs in our non-p value, and then after the decimal is where we find our sig figs in a p value. And remember, in a p value, only digits after the decimal are significant. And that's not the end of the question, because it said, what color will bromcresol green be in pH 10.72? And what would it be? It would be 10.72 is blue. Do you guys think you could do B and C? Okay, try B and C. And once you're done, you can check your whatchacolumns, your answers up there. If you are given the concentration of an acid solution, this is just a reminder, you already know this from Unit 4. First thing you must do is you must determine if the acid is what? Strong or weak? If it is strong, what tools do we use? Strong, we use stoic. If it is weak, weak acid, rice and Ka. So for example, if we have a strong acid, then hydrogen ion concentration simply equals the concentration of the acid. Because all the HX dissociates. Boom. And this is a 1-to-1 ratio. You don't need to show that. You can just say that. Okay? If it is strong. If it is weak, use a rice table and Ka. So please try example 3. Anybody need a data booklet? Anyone else data booklet? Yeah. And then. It actually is science. Yes. Oh. Okay. H2SO4 is a strong acid, so it dissociates completely, but only a first dissociation makes a significant contribution to the hydrogen. Because remember, anytime you have a diprotic or triprotic acid, the first dissociation is the only one that makes a significant contribution. So in this case, and because this is 0.025 molar, this is 0.025 molar.
Okay. It should be alright with like H3O.
Oh, H3O plus would be fine as long as you put a water there. Okay, you could totally do that and write H3O plus. Yes. Because in a diprotic acid, only the first dissociation is really important. So if you had, let's say, I'm just going to say H2X because I don't want to write out SO4 that many times. Those are going to dissociate into I'm regretting drawing that many. And only maybe one of these is going to further dissociate into H plus X minus, 2 minus, because that one is a weak acid, okay? Now, I've only drawn 6, but in actuality, it would be like all get rid of 1, maybe only 1 in 1,000 undergo the second one, yeah? So we have negative log of 0.025, which is equal to 0.025 log 1.60. And therefore, Braham Cresol green is yellow. Do you guys feel good about tackling example 4? Okay. So what I want in these blanks here is that concentration the initial concentration or the equilibrium concentration? 0.050 solution of the weak acid. That is our initial. And HCN is what type of acid? Weak.
We're trying to find a pH of this.
We are trying to find the color of chlorophenol red. And if we're trying to find the color of an indicator, that means we need the pH. So yes, we're trying to find the pH. Yes. Did I square root it? Oh, no, I didn't. I knew I was doing something wrong. Okay, let's fix that. That is 1.57. All right, and then pH of 4.81, we are trying to find out the color of chlorophenol red. Did I do it wrong? Uh-oh. Good Lord, what is wrong with me? Okay, 0.05 times 4.9 times 10 to the negative 10 So that's 2.45 times 10 to the negative 11. Oh my God. Okay. That look better?
Yeah.
Okay, and now we have to take the root of that. Okay, root. Okay. And we get 4.9 times 10 to the negative 6?
Yeah.
Okay. Okay. La 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 la. Third time's a charm, right? Okay. 4.95 times 10 to the negative 6. 4.95 times 10 to the negative 6. Log. And we get 5.31. Huh. Finally. Okay. Therefore, chlorophenol red will be what color? Chlorophenol red at 5.3, which is right in here. So it will be between yellow and red. So it will be
Uh,
5.3.
it'll be like. It'll be like orange now.
Just say orange. Don't say yellowy orange. Don't try and be like fancy about it. Just say orange because it's within the 5.2 to 6.8 range. It will be orange. On Earth? Oh. Does that all make sense? Easy peasy? When given the concentration of a base, you must also determine if it is strong or if it is weak. How do you know if you have a strong base?
I mean, there's only two strong bases.
There are only 2 strong Bronsted-Lowry bases, but there's lots of strong Arrhenius bases. And what are our Arrhenius bases? Metal hydroxides. And unlike the acids where the first dissociation is the most important, it doesn't matter whether you have a 1 or a 2, it goes to completion. Okay, they dissociate to completion. So you would end up with 2 hydroxides here and 2 hydroxides here. So whatever your concentration is for the calcium hydroxide, concentration of hydroxide will be twice that much. Yes? So could you please figure out the color of thymol phthalate in 0.0030 molar barium hydroxide? So write your dissociation.
A one-way arrow for this one.
Yep, because these are strong. And there's two pathways to go from hydroxide to pH. You can go from hydroxide to hydrogen to pH, or you can go from hydroxide to POH to pH. Yes,
On the liquid other fluid.
that one. Thank you. My brain is sloppy this morning. And then you look up thymolphthalein on your table, and it is 11.78 is up here. So that's going to be blue. We will soon learn how to determine the pH of a weak baked solution. We have! But we haven't covered KB yet, so we won't deal with it on this worksheet. But we have, so there we are. Okay. Finding the color in a mixture of indicators. What color would a solution of pH 6.4 be if the following three indicators are present? So we have pH 6.4, and we have thymolphthalein, neutral red, and methyl red. So what you have to do is you have to say at pH 6.4, what color is phenolphthalein? It is colorless. Oh my goodness, I saw a Canadian write favorite and I could not get over it. I'm like, that just looks so wrong, right? It just, no. Like even, like sometimes I can kind of get over color because you see it so frequently in American publications and stuff, but favorite just looks so wrong without the U. Anyway, why is it not erasing? There we go. All right. What color is neutral red at pH 6.4? It is neutral red. It is red. Yes. And methyl red is
It'll be yellow.
yellow. So if we take those three colors, colorless plus red plus yellow, what do we get when we combine them? We get orange. Okay, so that's not that difficult. You just have to, read your table and know your color combinations. Okay? This next bit is the hard bit. Okay, and I'm sorry. There is a lab that you can do with this, but we're just going to do it on paper because we're running out of time. Okay? A lab is performed with 3 different indicators: HIN1, HIN2, and HIN3. And those 3 indicators are going to be mixed with HCl, NaOH, HA1, HA2, HA3. So in like a little spot plate. Yes? So each one individually. HA1 is a weak acid, HA2 is a weak acid, HA3 is a weak acid. HIN1, HIN2, and HIN3, what type of acids are those? Those are
Acid and strong base.
weak acids. HCl is a strong acid. And NaOH is a strong base. So here is what we get to see in each of the spot plates, in each of the spots on the spot plate. So when we mix HCl with indicator 1, and you'll notice indicator 1, I've written both forms, HIN1 and IN1 minus, because the indicator 1 is both of those. Yes? That turns the solution red. What information can you get from that? Which of those 2 forms of the indicator is red?
HIN1.
HIN1 is red.
So like, how do we know that again?
How do you know that? Well, if you had your equilibrium of, and I guess its other color is going to be yellow, okay? So if you had HIN1, which we're saying it's red, okay, but let's just assume for the moment we don't know that, and it is in equilibrium with H plus IN minus 1. And if we add HCl, what happens to the concentration of H plus? Concentration of H plus increases. And if H plus increases, which way does the equilibrium shift? Shifts left. Towards HIN1. Towards, TWDS is towards. Therefore, HIN1 is and it turns red. Therefore, HIN1 is red.
I'll use red and acid.
Yeah. Now, what if we add OH minus? NaOH, which is what we do in the next little spot. Yes, here it's yellow. This one was red. If we add NaOH, it's going to turn yellow. So if we add NaOH, the concentration of hydrogen in this equilibrium does what? Does it increase or decrease when we add OH? Hydrogen decreases because H plus reacts with OH minus, producing water, which means that we have less of this. Yes? And if the hydrogen ion concentration decreases, which way does it shift?
Right.
It shifts to the right. And when it shifted right, we saw from the results that it turned what color? When we added NaOH, it turned yellow. So when we added NaOH, it turned yellow. And it shifted towards the right. And what's on the right of that equilibrium? H plus and ion minus. H plus has no color, therefore it must be ion minus that is yellow. Could you go through the results for HIN2 and HIN3 and figure out what color each of those things is? And I know you don't have like 7,000 colored pens like me, so I'm just going to write red. And this one will be yellow. You're going to do the same thing for HIN2 and IN2 minus, HIN3 and IN3 minus. Can you go and figure those out using the same logic? If you need to write things out and there's not enough space on here, please feel free to get yourself a piece of scrap paper. Yeah, perfect. Everything can just go in here.
I don't know where I'm at.
Your bubble sheet? Did you leave it in there? If you're having trouble figuring it out, if you add H, which form are you going to get more of, the H form or the no H form? You've added more H, you're going to get the H form. So that means that the H form must be yellow. Does that make sense? No, it doesn't make sense. I got nobody going, yeah, cool. Okay, so you need a piece of scrap paper then, because there is not enough room on here. Go get a piece of scrap paper. Go. Yeah, that's fine. We'll put them away next day after they've dried. Okay, now I have room, so I'm going to do this over here, but so we have HIN2. And what's on the right-hand side of that equilibrium? H plus and IN2 minus. Now we are told that we add HCl to HIN2. That gives us yellow. If we add HCl, what have we done? We have increased concentration of H plus. Therefore, that equilibrium is going to shift left. So we added HCl and it turned yellow. We added HCl and it shifted left. So which of those two species is yellow? HIN. Yeah, HIN2 is yellow. Okay, that it shifted left and it turned yellow, therefore HIN2 is yellow. Now, the second thing we did is we added some hydroxide to it, yes? And when we added hydroxide, it turned blue. Are we all okay with reading this little chart? You just go across and down at the thing. Okay, so when we've got NaOH, so we add NaOH. And it turns blue. Now there's no OH in that equilibrium. But does OH affect that equilibrium? Yes, because OH minus reacts with H plus, form water. And that means are we making H plus or using H plus up? We are using H plus up. And therefore, the concentration of H plus does what? Goes up or down? It goes down. And if it goes down, which way does the equilibrium shift? Shifts to the right. And if it shifts right, what color does it turn? Well, we know it turned blue. It turned blue and it shifted right. What species is on the right? Ion minus is on the right, therefore ion minus must be blue. So far, so good? Okay. Now, you don't have to draw this little equilibrium thing every time and write the therefore this and the therefore that, because I feel like the fact that if I've got more H, I'll end up with more of the H species. Yes? And if I've got less H, less H, I'm going to have less of the H species. And that's going to mean more of the ion minus. And if you want to get even more simple than that, if you add a strong acid to the indicator, you will see the acid form of the indicator. If you add a strong base to the indicator, you will see the base form of the indicator. Okay? If you add a strong base to the indicator, you will see the base form of the indicator, ion minus. Yes? Ms. Spence is lazy, does not want to write the same sentence twice. Yes? Is that making sense? Okay, cool. Could you predict then, okay, so we agreed that HIN2 was yellow and IN2 minus was blue. So this one is yellow and this one is blue. Could you quickly, looking at HIN3, tell whether IN3 HIN3, is it red or is it blue? IN3 minus, is it red or is it blue?
Yes.
Yes. What is HIN3? HIN3 is red, and IN3 minus is blue. Okay. And now we're going to mix weak acid with weak acid and weak base with weak base. So you're going to end up with an acid-base equilibrium where you have the indicator acid on one side and the indicator base on the other side. So what we're going to end up with is when we mix any of the HINs with any of the HAs, let's see which way I wrote it around. Okay, I wrote the HAs that way. Okay. Did I? Yes, I did. Okay. So if I have, let's just put HA on the left-hand side, and let's put HIN on the right-hand side of the equilibrium, because each side of the equilibrium needs an acid and each side of the equilibrium needs a base. And remember, when I say HIN, I really mean HIN, IN minus, and I really mean HA slash A minus. So I'm really combining not just the acids, but also the bases. Because they're weak, there is a mixture of both. Yes, anytime you have weak, you have some of the acid and you have some of the base. I see perplexed looks. Any weak acid in water, no other acid, will be present in both its base form and its acid form. There will be some of each. A minus is the base form. No, that's okay. I saw puzzled looks and I'm like, we need clarification, right? Yeah. Don't be shy about asking, because anytime anything is confusing, it should be clarified. Yeah? In any weak acid, there is also weak base present. So if I've got HA on the left, which of my four species is going to be on the left with it? If I'm mixing HIN and HA. HIN is on the right. So I've got HA. I've got HIN. Where does IN minus go? Does IN minus go here? Or does IN minus go here? It goes on the left. Because remember, conjugate acid-base pairs are on opposite sides of the equilibrium. And that means where does A minus go? It goes on the right. Okay, so now we have a weak acid base equilibrium.
So it says we A1 minus.
Yep, so now what we've done is we have added,
The new table.
no, same table. I'm just, because I want to reference it and I'm on the next page now, I've just rewritten it. Okay, it's the same table as before. But when I've got HIN1 and IN1 minus and HA1 and A1 minus, I get the color red. Yes? So what we have to ask ourselves is, if I see red, and remember what color was HIN1? HIN1 was red, and IN1 minus was yellow. So if that's the case, and if I have HA1, which is red, whoops, plus IN minus. Oh, what am I doing? No, HA1 is not red. Who's red? HIN1. That's not red. Oh, I'm so sorry. Like I said, messy brain this morning. Monday morning brain. This one here is red. So if we see red, which side is favored? Products or reactants? You guys are killing me. If I see the color red, which side is favored? Products or reactants?
Reactants. Oh, the product.
Products are favored. So if we see red, products are favored. So who is the stronger acid, HA1 or HIN1? Do we favor the weak side or do we favor the strong side? Your homework
Is finish this table.
is page 20. It'll be on Teams. 21. And all of page 21. You're welcome.
This is my lap.
Thank you. Thank you. Dorothy. How you doing? You're almost okay. Yeah, I appreciate that. Really do. I'm gonna have lunch, but no. See ya. Oh, okay. Where's your? Yes. Uh, oh. Okay. I'm sorry, what's the program you? Okay. Okay. Basically. Okay. Okay. Right. Okay. Those all sound very cool. As was the software. Yes. I think if you want to just go somewhere. Their co-op program is amazing. Um, like you're gonna come with a specific set of rules. Right? This is what I do, right? The reason I say this is because my son was like, he integrated now, right? So like he put off the food further. On the other hand, like if you want to have a classical view. Yeah. Right? Yeah. Yes. Toronto's my city. Yeah, so I mean, other than the university, like, it's not all much of like that anyway. It sounds to me like people are. What I heard from what I'm saying, they don't get much out of it. Okay. Where do you go? Okay. Full life there? Oh, yeah. I know it's a few years ago. Check on Reddit. That's not gonna go well. No, I mean, it's not like that program has been made so bad. But it's like, that program is like the most competitive one to do. I don't know. That's a tough question. Yeah. It is gamble. Bigger for me, and you have to bear in mind that I'm really biased on this one. Because my son is in home, so for a job right now, and is not succeeding. And I'm soon, right?
Just a reminder, there's a health and safety meeting right now in room 214.
Skills that are specific to what the jobs are hiring for. Right? So, yeah, so I think what's gonna happen is, probably, what's gonna happen is spend a year looking for a job. And then I'm probably gonna say, why don't we, say, like, you apply to the CSU for their phone line or whatever that comes after three, because they do the things after. That's my auto line, right? Right? Especially probably people take free. It's a free. Good, really good. Oh, yeah, common. Oh, yeah, people eat. Oh, yeah. If they was. Oh, yeah, but when you go to Carolina, you have to find a company that was kind of or special ed. And because he did special ed, and like I said, this is my bias because I have a son who's like not specialized in anything really, right? But he was kind of there. Yeah, a little bit of everything. But yeah, so right now I would be like, take the thing that gets you the job. But yeah. Yeah. It's software. Yeah. How software is working right now. Yeah, I was talking to like yeah. Yeah, because also AI. Yeah. Yeah. They're cutting out people. Like, what if I was going to try it? Like, what I learned, they were going. Yeah. Like, that's really interesting. Right? Yeah, that is that. So, who have their phones? Yes. Okay, so going for tea, make sure you find some internships. We'll work with professors or whatever. No, it's not happening on the project. That's been requiring to like. That's all a little bit. That there's right this one. Yeah. 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 Yeah, but it sounds like you wanna go to uni. I love that. There's right now. Well, yeah, but you go out there and you can't produce and everything is terrible. You know what? And you do something. Yeah, no. Like, why would you not stop doing that? Right? You have to spend your first year there and you're like, I hate engineering. I hate this program. And other options. Yeah. Right? And even if it's something like, okay, I don't want to do that. Right? I don't want to get a job because it's I don't know. It's really fun. Yeah. It's not a happy program. It's really like program. You can go and get right? So you can have options. Yeah. Yeah. I saw so many people that I didn't get out of the yes. Wow, like that's such a big player. Yeah. Yeah. I think it's very. It's okay, but yeah, like he's guaranteed. Yeah, he's guaranteed. Yes, like he will. Yes. And he seems happy enough to just, chugging along at home, applying here and there and keeping off a lot of decent amount of money and having nothing I would say what next. Do you know what I mean? Like we're not if we were in a situation where, I was strapped for money and his dad was strapped for money and whatever, then going to city right now, get a job right now, right? Yeah. He has no pressure. But we
have to get no particular pressure within one to be able to put over the seat. Yeah. So maybe by that time you will have a job. Yeah. And then we don't need to go through that. Exactly. That would be exactly. Maybe I'm like, catastrophizing because I am also one of those people who's like waking up with nightmares. Not about my own life, but about this life. It's not good. That's not how stress. That's how the worst so much. So all I stress about myself is, I'm well, like this, yeah, everything. Yeah. So. Yeah, I mean, I feel like I would regret it. Then, you didn't, but I saw this. The last girl told me, like, I can change out of and yeah, they said I could do specialized. Right? I can change to any. But yeah, what's the point? Well, that's not great. To be honest, that sounds great. Because I'm curious. This is the area that looks like it's top road, right? Or this is what I'm really interested in, you know, it's just something I like that. And we can put out, right? I'm thinking it's we'll be happier, more content, and more social. But after that, that was about, there you go. Good to see this. Yeah, so much. What is this like? I don't second one. I thought that then like, okay, technically my dog, but like, because you can choose one person. Right. My water was that show water, so right. Okay. I have to tell how I before I'm water, you know, and then I think like skiing. I didn't sound fun to do so no one knows where I'm going. Well, yeah, and then the college we're talking about there's a lot of stuff. Yeah, right. Like you can go and see it and go. So how was seeing you there next year? And people like literally almost like water just was the lowest rate in middle school. Like almost okay. I was so sad my grade. And then we compared it to water. Social life. I was like, okay, no social life, but happy. I don't know how that works, but somehow that worked out. Yeah. But I was like, you know how to make it work? Yeah. They don't have social. Yeah. 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 These are not one of those price. Sounds like that's good. That's what you want. It's good. Yeah. About 7:30. So I something almost. Yeah. Late, but yeah. Change my mind. Here I am. Yeah. I did. That's great. Why did you just not tell me? Just listen. You just have to get yeah. And look at it, AI putting everything out there. Like it works like I like smart go the other way, but like it's what's that? This is pretty smart. No, it's really not. easy. It's gonna be the rise.
Yeah.
No, it's.
Yeah, I feel like those people, but.
Oh, we were a little like, or when they started. Why do like the city far? I don't know, I still feel like that's why we go through like grad there. But if we're like school, we're not like it didn't feel like it. But people are like, did you guys cry? But I'm gonna see these. Yeah. Last judge? Yeah. I think the last day of school. So I was like, not yet. Yeah, maybe later. Yeah, that's what we were talking about. You're like, but then you're like, oh, hi. I'm so sorry, I'm gonna miss you. Oh, hello. That's so true. Yeah. Wow. Everyone's been really happy. Yeah. If I agree. Yeah. I agree. One of you. Wow, I guess I'll go so that I'm not starving too much. Glasses.
Yeah. Oh, and I have to turn this thing off too. You are welcome.